Jerome, if you want to add anything, feel free to stop me. So this is an NMRG virtual meeting for April. We will start with a brief introduction for the meeting logistic and the agenda, and we will switch after that to the technical presentation. First, a couple of reminding slides about the goal of the IETF. So the IETF conducts research. It is not a standards development organization. The IETF focuses on longer-term research issues related to the internet, and our let's say, affiliated or sister organization, the Internet Engineering Task Force, focuses on shorter-term issues of engineering and standards making. We would like to make it clear the distinction between both. And IETF can publish informational and experimental documents in the RFC series. Its primary goal is to promote development of research collaboration and teamwork in exploring research issues related to internet protocols, applications, architecture, and technology. And you can get more information, for instance, in the IETF primer for IETF participants, RFC 7418. Okay. Following that, we have also some policies. The IETF generally follows IETF policies, and this is the so-called Note Well. Just as a high-level reminder for you that this is a reminder of the IETF policies in effect on various topics, especially regarding intellectual property or code of conduct. So these are important elements we invite you to be aware of, and especially as a reminder, by participating, if you agree to follow IETF processes and policies, you're aware that any IETF contributions is patent application that are owned or controlled by you or your sponsors must be disclosed. As a participant or attendee to any IETF activity, you acknowledge that written, audio, video, and photographic records of meetings may be made public. And for your information, this meeting will be recorded. Personal information that you provide to IETF will be handled in accordance to the IETF privacy statements. And as participants or attendee, you agree to work respectfully with other participants. And if you're facing any issue, please contact the ombudsman. And you have a set of other best current practices documents that give you further guidelines on these IETF policies. Now that we are also conducting more virtual meetings, and especially with a series of virtual interims that have been following the IETF 107 that was held fully virtually, there are some kind of global etiquette across research group and working groups, so we would like to highlight a few points. Please remember that all sessions are being recorded, as it is the case for this meeting. Make sure that your video is off to save bandwidth. Keep yourself muted unless you are speaking. We will handle the queue through the WebEx chat, so if you want to make a comment, please type RH in the WebEx chat. To means raising hand, you want to say something. And if you want to remove yourself from the queue or not have any more comments, you may type LH, and the chairs will handle the queue. Okay, and when you are speaking, please, for the sake of time, please stay to the point, be concise and precise. I hope everything is clear until now. A few links. I think if you're already online, it means that you know a bit how to navigate, but this may always be useful. The agenda materials are available on the IETF data tracker. You have the Etherpad, which is a shared pad. You may add your notes, participants, etc. to the pad. This is also what we will use as a basis for the minutes. The recording will be made available after the meeting. And please, as said, please add your name at the bottom of the Ethernet page. It's very useful to track attendance. Overview of our agenda for today. We have a pretty packed agenda, a lot of topics we would like to cover, and especially initially we had planned to have 2 sessions in the IETF 107 meetings, so we wanted still to be able to cover most of those topics. So this will be a bit a long meeting today, but we hope you can stay with us until the end. So this is the current first slot, meeting logistic agenda. It will be finished in 1 minute. And then we will start our technical presentations with Pedro for intelligent reasoning on external events for network management. And then Sonia will give us an overview of their work in Telefonica on metadata-based aggregation of telemetry flows. We will have then New coming from Milad on fault tolerance for service function change as an introduction of their work. And we see also connections with some other activities in IETF on SFC. Then a new draft coming to the NMRG with transport slice intent from Luis and Panayotis, coming from based on some work in a European project. Then automated design of network services from network service requirement is a research article, research work. It is also in the scope of IBM work plan. Then we have some draft in NMRG and in Ops area working group intent classification with Chuyan will give us an update on the current document and some discussion on the next steps. We will have Benoit giving us an update on assurance for IBM architecture, which is Ops area working group, but is of course of interest for the IBM. Definition. And finally, we hope we have still time to give you the main research group updates at the end of this meeting. I hope the agenda is fine for you. If you have any questions or changes, please let us know because it's very packed and we would like to start right away. Jérôme, I don't know if you want to add something or if we can move on.
No, nothing more from my side. Perfect. So.
Pedro, I will project the slides and you just tell me or when you want to move to the next slide. Okay? Roughly 10 minutes for presentation and we try to keep time for questions for every presentation. Okay?
Okay. Okay, can you hear me, isn't it?
Yes.
Okay, so let's go.
So
I don't see it. No, don't see the still the agenda on the screen. Now it is changing now. Okay, so as thank you very much, Laurent, for presenting, for introducing me. I will just present this update on the draft I'm working on. It is called the Intelligent Reasoning on External Events for Network Management. And please, next slide, please. I have been working on this together with Homasan from NTT to mainly particularize the requirements from network slicing for especially from this AI involvement in network management. So first, the quick context that we have is the AI solutions must work in symphony with other network management solutions. So they allow networks to grow in complexity, deliver faster decisions, etc. So, but current machine learning solutions work only on performance data. Normally, the other AI solutions require more information, and intelligent reasoning solutions need to collaborate with network to retrieve topology, real-time situation, etc. And they need some special efficient semantic representation and exchange of network data for this adoption of in AI and network management. Okay, this is the main context. We have been working on research challenges and research topics in this overall integration of different, not just machine learning, but different kinds of artificial intelligence solutions in network management. And especially, again, I insist that we have been working together with NTT to get requirements from network slicing in order to fulfill this involvement. Next slide, please. So our objective has been now to mainly to gather this information for getting the most benefit of the application of this in reasoning mainly, because for now, as we can know, especially from the last ICI conference, it was very clear that the current status of research on automation and similar tools for the network management is mainly focused on machine learning. So it's not a bad thing, but what I mean is that we have exploited the learning phase of intelligence very well. But now we have to move forward, and in the artificial intelligence world, we have the next step, and it was also commented in this latest conference of ICIN. The next step is reasoning. So what are the requirements in this sense of from reasoning to exploit the to exploit artificial intelligence in network management? So we aim to define some gaps to this reasoning application, and what will be the challenges to integrate reasoning into the network management world. Next slide, please. So I think that we can skip this slide. Please go to the next one, because we have the background. I will just comment it. So we have different kinds of network systems, that were virtual computers, SDN, etc. And we are also focusing on management and slicing. So this is the context is very, very straightforward. And now I will focus on what will be this application of AI to network management. As I have told in previous meetings, I already introduced, I am working on this concept. And in the latest draft, version of the draft I am working on, we are emphasizing this. So to apply the AI to network management, we need to move beyond machine learning. Machine learning is a very specific tool, and it has very specific way of doing things. Like it requires one formalization of information in vectors, etc., and some very efficient, or even though it can be computational intensive, but it's very efficient calculations to get some kind of model that after that can be exploited. Okay, but that for now is it would be very good for answering the question, is there a problem in my system? But now we have more complex questions, like where should I migrate this virtual machine to accomplish my goals? Okay, so intelligence is needed for this. And the new functions, for example, that answer this question allow network devices to be more autonomic and can be fed to the animal world. Next slide, please. So one key that we are working on this is to extend management operation to achieve some kind of intelligent network management process. And this, in this sense, we have four, to make the decisions, we have 4 key points. First will be retrieving the information in sense of different like performance measurement, but also other kind of information from the databases, external events, etc. And this information is fed to current, for example, machine learning tools, and we obtain the model. After that, we also execute the reasoning process. Reasoning processes will infer new knowledge and rules, etc., from this information and models, both together. So we have new rules that will be also fed back to the model. So it will be constantly building a better view of the network management from the management point of view. In order to go to this next step will be to solving potential problems. This view will find problems, and some specific operation process or whatever it's called will be executed in order to resolve those problems. So this will be the solving part. And finally, once the solution is found, we have to plan how to implement that solution into the network, how to require the network to adjust the amount of resources that are involved or things like that. So these 4 processes will be executed, and one key point is that they are executed in parallel. So there will be interdependencies, but also some way of independence from them. among them. So it is a very tricky way. So there are challenges, there are interface definitions that we must consider in order to make all these processes work together. Okay, we also have been working on the what we call the closed control loop management approach. That means that once we have these previously mentioned processes, in order to achieve management goals using them, we enforce the resulting decisions, and after that we constantly check that the decisions are being effective. No, so what we do is that we close this control loop. So in one way or another, these processes I mentioned before, they will be required to connect their outputs to their inputs, but in different kinds of, in different ways. So some planning will be connected to solving, etc. So at the end, the objective is that data plane elements will be involved also in this reasoning, because they must provide some even small information to check that the enforced decision is taken is being effective. So we need that. Okay, next slide, please. So what we the main way, to execute those processes would be by a specific, so it's a general shift, of the metaphor of network management. So in this way, exploitation of AI in network management, what we do is that we begin with data and we want to achieve wisdom. So all AI solutions become more like being able to take this kind of strategic decisions by getting data, processing the data, getting information, what is called, the data formatted in some kind of information. Then from the information we reason, we obtain knowledge, and we build what we are familiar, the knowledge base. But with that knowledge, after the application of knowledge, after the exploitation of the knowledge, what we get is that it's a system, it's a wise system. So what we get is wisdom. We are also in the draft focusing. We are also introducing the achievement of this target, the wisdom, by executing the 4 processes of AI I mentioned before. We exploit all the knowledge information, or sorry, all the knowledge stored in the knowledge base, in order to achieve a system that is more wise. So we achieve this wisdom. Okay, so that will be the key of this exploitation part. So next slide, please. That will be the last slide. I don't know how if I am on time or not, but I will just finish. So for now, what we are identifying in this draft is that the challenges we are now facing are the reason on network behavior from performance measurements and external events. That's our main challenge we have mainly identified right now, in the sense of network slicing, from network slicing part. So the gaps, what we find also identified, that would be, we need some method for allowing different providers and method and vendors be able to coexist and work together. That means that they can exchange information, they can understand to each other in the terms of this intelligence data, and as I mentioned before, the wisdom of that they obtain from all these processes. So one key point also, what we have identified in the draft, is that we need some kind of method for the assessment of the quality of the AI. That means that if we have different algorithms, different modules, we can benchmark some way modules, but not just in that sense, benchmarking to know the performance or something like that. No, just where I am more focusing on assess that they are working as they are expected, because one key difference is that today when we buy or when we integrate some component, physical or logical component, they normally we expect they work well. No, we are not let's say we can be deterministic, in the sense that we know that it will work in some way. But when we are introducing some AI module, we cannot be deterministic. We cannot know, we cannot be sure that the module will work. So we need some way to assess the quality of the module. That means that the module will work most of the time. That's it. Not just things like MTBF or things, something like that, but something more focused on the intelligence. Is how smart, how much is this intelligence of this module? Okay. So and in order to achieve these gaps, to fill these gaps, we have also identified that we need some consistency from ontological concepts. So different vendors again and different providers can coexist and understand to each other. So the concepts must be ontologically defined. And finally, what we have identified is that the protocols used to publish the information must respond to some constraint on the target usage. That means that, for example, when we are sharing some data, some information of knowledge items among different providers, different modules of that will analyze that information, we must be sure that in some software or even organizational contract, they will do to the information what we are expecting them to do, not just in the terms of security or privacy, but in terms of what I mean again is a software contract. No, that the target model will do what we are expecting it to do, and that's what we have right now. And from now, what we are our main target by sharing this draft in the NMRG is mainly to ask other contributors for the in the sense of both structure for the application of AI to network management, but also, of course, in this kind of challenges and gaps for this again for the completion to achieve more complete spectrum of the work that is required to fully exploit the application of AI in network management. And that's it.
Okay, thank you, Pedro. Is it the end of your presentation?
Yes, of course.
Okay, so we have, I suppose it should be Marie-José acting as Coin Research Group in the chat, raising hand, so maybe she has a question.
Yeah, I'm sorry. When you go into WebEx and you use whatever account, I'm not here as the CoinRG chair. I'm here as a person. Okay, I have two questions, comments. I think it's interesting that you didn't mention data sets here. You talk about ontology, but it's more than that. It's the data set. What are the data that you're going to use for what you call network management? And they should be problem specific. There's a ton of things that happen in a network that are completely disconnected. So what do you mean by having this very generic reasoning? The other one, you seem to be kind of confused about the role of machine learning. Machine learning is not just accumulate data for income learning, it's also to infer on that learning, what you call the AI part. So again, if you have a good data set and you actually have your machine learning, then your system becomes by itself autonomous. And when you say that you need to know if the information is right or not, well, that's actually what machine learning is designed to do throughout the machine learning process, either by automatic decision making or by annotating by experts. So, you know, while you train your algorithm, you can have inputs from experts who say, well, this is the behavior that we expect. So you have your training set. So I think what I see is that there's a lot of good stuff in there, but there's a lot of things that seem to be incomplete or mixed up. So do you intend in your next version of your draft to make this more clear? Because right now it's too vague. What is the problem you're trying to solve?
Yes, that's I'm sorry. What for now, we are not focusing in just one problem, but again, I insist to gather these kind of challenges. Okay, I understand your points. What I am more in this sense, maybe it's not so clear the difference that we are trying to clarify here, in the sense of this particular difference between the learning phase. Not just, I am not saying that machine learning only gathers information. Machine learning is what it has. It builds a model from the information that we have. It builds a model of knowledge. It's okay. But the inference that machine learning has is just for the output of this information. What we want is to go beyond that inference, to do reasoning on that inference. Let's say, not just learning and stop there, but build a model, okay, but dynamically change the model. In order to do that, we must establish new rules and new ways to do that. So the idea is that after machine learning process has finished, okay, we can take decisions with the output, but what the next step would be those decisions, those outputs from machine learning would be reasoning beyond that output in order to obtain meta information, let's say information about the machine learning tool, and let's say change that tool with new rules and new conditions, etc., that the reasoning operation is doing in that sense. After that, I insist that we have the planning, etc., but it will be beyond. But the main point right now, the next step right now would be to exploit this reasoning part. And we want to clarify that. So if you want, for example, collaborate in this draft in order to clarify the point, the involvement of machine learning in all this process, we are open to new collaborators. It's our target right now. We are not focusing in specific problems, but we are more wide spectrum to define the challenges and gaps and find collaborators that can provide this kind of details that we are missing in the draft.
Okay. So thanks, Marie-José, for raising your points, and thanks for Pedro trying to address them. We are a bit tight on schedule, so my recommendation, and because I think this is good discussion, and is to follow up with your draft, maybe with addressing on the mailing list the comments raised by Marie-José, trying to develop further what could be your common understanding on that. As you will see later, Jerome will present also, we are introducing a new document on research challenges for AI network management. I believe that some of your inputs could really go to these documents also to contribute to these other documents. And as we have seen, it will be nice also if you can try to I would say, develop a bit further the next step for your documents and going from this, I will say, more high-level views, but more concrete proposals, how we can, I mean, develop this further in the NMRG or elsewhere, but at least from your initial vision, what can be the next steps.
Okay.
Okay, final remark, but this we can also work offline as properly raised in the chat. I mean, we see that you have a confidential tag in all of your
I'm
slides.
just removing it. I'm sorry. It was
Yes, we have not seen that when we accepted the slides, but I think it will be better if you can send us a revised version without this confidential.
I'm just changing it right now. I will send them.
Okay. No worries. It's okay. It's fine. Thanks, Pedro. Okay, so give me time to switch to the next presentation, which I think will be Sonia. Just we're running already a bit late with respect to our planning, so I will ask our presenters to really try to be to their time and also for the questions. Also, thank you. Sonia, can you see the slide?
No. No.
I can
Now
see.
I can see. Yeah, now I can see it.
Okay.
Okay, so good afternoon. My name is Sonia, and I'm working in the Transport and IP Network Division in the Global CTIO unit in Telefonica Research and Development. So a bit introducing myself. During the last 2 years, I've been working in different European projects regarding new telemetry mechanisms for network devices in 5G networks. So in relation with this, now we are exploring about metadata-based aggregation of telemetry flows, which is the main topic of this presentation. Next slide, please. So for this presentation, we are going through a short introduction, followed by the description of the standard in which we base our initial work. And then we will see the initial report of our work. And finally, we will state some conclusions and the request for this research group. Next. And next one, please. As you already know, over the years, telecommunication networks have evolved in order to address the demand of the new services. So the increasing number of nodes that forms the networks and their advanced capabilities, the evolution of the underlying technologies and all the different ways to access the network has turned telecommunication networks into a very heterogeneous networks, not only regarding the technologies, but also traffic requirements from the provision of different services. So this situation raises a new way in the network management in which the data is the key element for handling these heterogeneous networks. Next, please. In these data-oriented networks, in which is necessary to handle the heterogeneity of all of these components, it's important to offer data in a consistent way to all of the different service applications needed for the closed-loop automation systems, such as some application about artificial intelligence or big data or whatever. So for this work, we propose the use of a semantic metadata framework for aggregation of all of the data coming from the network. Next. So this semantic metadata framework is based on the idea of using a model to describe the different network elements that are present in a data flow. This metadata will not be used for sending the data itself, but it models the data that a device is capable of providing. So by using this semantic metadata framework, the different data sources or flows will be described by means of this metadata, and it would then be necessary to adapt all of the control elements one by one. So apart from this, the application of this semantic model will imply some changes in the current definition of the descriptors, but as we are in a very early stage, we are not focusing in this part yet. Next. So for the starting point of this idea of defining a data framework is based on the ETSI standard called Context Information Management. So I'm going to introduce you a little bit of this concept. This standard defines an API for context information management, enable access to the information coming from many different sources. So for implementing this, the standard provides an information model that defines the structure of context information that must be supported by the system. Initially, it was thought for IoT data sources, but the scope is not tight for these data sources. So this standard allows users to provide, consume, and subscribe to context information in different scenarios. Next one, please. So besides the SIM standard does not define a specific architecture for implementing this system, they provide some recommendations about 3 possible architectures: a centralized, a distributed, and a federated architecture. Nevertheless, the 3 architectures have the same key components that are the ones that you can see here, which are the context consumer, that is basically the application that needs this context information of the data sources for requesting one information or another, the ones that fits for their application. Then it is the context producer or context sources, which corresponds with all the data sources that produce some data, and thus they need the definition of this context data. Then there is a central piece, which is the main one, which is the broker, is responsible for handling the request from the consumers, the application, and asking the information to the source. And finally, depending on the architecture that you choose, there is another component, which is the context registry, which is a component that can be in the broker or can be in a separate one, in which basically the data source register the context information they can provide and is available to be requested by the broker for the corresponding request done by the consumers. Next one. So as you can see here, this is the proposal that is in the standard for a distributed architecture. As you can see, all the interactions between the consumers and the source are done through a broker who requests the context information of the data sources to the context registry. And the context source previously were registered in the context registry. Next one. So as I said before, this standard provides an information model that defines the structure of the context information that should be supported by the system that I shown in the previous slide. So this information model relies on the idea of having an ontology, which basically provides the definition of a set of concepts, their taxonomy, and the relationship that governs these concepts. So these figures show a UML representation of the information model defining the standard, which is composed by different entities, relationships, and properties. Next one. So now, once the base for this work is present, we are going to see the initial steps we went through for applying this to the telemetry metadata. Next one. So one of the final goals we have for implementing this work is trying to build a generic patterns for metadata definition. However, until reaching these general patterns, we start first collecting multiple context sources that we will have available in different scenarios, and an initial static definition of some information models for this context source that we identify. So at the same time, we are defining all of these information models. We would like to start building a semantic aggregator, or the broker, this is called in the SIM standard, by making use of tools already available in the industry for making preprocessing of the data and the interaction for the different modules of this architecture. And finally, all of this work is trying to be aligned with the SIM standard as much as possible as we take it as a reference. Next one. Apart from that, we start to think how can we integrate this semantic framework into a general and a common architecture using the current projects that we are working on. So as you can see here, we add the semantic aggregator plus the context registry in two possible domains, the network service provider domain and the local one. These two domains will be able to interwork also in this level, and by doing this, all the elements available and allowed by the network service provider can be used by the local semantic aggregator to be requested by the local service application, such as artificial intelligence, some monitoring platform, or whatever application it's needed in the local domain. Next one. So here you can see some of the data source we have already identified in the projects that we are working. So some of them are network-based profs, such as an ICMP prof, HTTP, DNS, IPFix, and so on. And we are also considering devices that already defines the information through a YAML model, and for example, data located in some time series database. Next one. So starting from in the next two slides, you will see some examples of the information model we start to define for some of the context source that I shown before. So in this case, in this slide, this corresponds to the information model for a network-based prof, such as an ICMP prof. So as you can see, it follows the SIM standard, in which the information model is composed of different entities, the white boxes, properties, and some relationships between these entities. So apart from the specific things of this context source, the ICMP prof, this information model implements two important characteristics. The first one, how is the information structure of this ICMP prof by the definition of the schema property, as you can see with the YARM dictionary. And the second property will be how this semantic aggregator, the broker, can reach this ICMP prof by the definition of the entity endpoint characterized by the entity URI. Next one, please. So the second example will be for a YAML-based device. So we are still defining this information model, and it could be sound a little repetitive because the YAML data models have already defined the structure of the information a network device can provide. But the idea of the semantic aggregator is trying to unify all the possible data source needed, and not all of these data source implements YAML data models. For this reason, we thought that it would be good to take advantage of the already defined YAML models in the device for inferring the properties for this entity device that owns multiple entities of YAML model. Next one. Next one, please. Yeah, is the last slide. So as a summary, we have been seeing that the data-driven network management requires the aggregation of the heterogeneous sources of data that we have to the different services that are provided and all of the devices that conform the networks. Also, as we have previously commented, we aim to extend existing metadata model for IoT environment to the network management environment. And finally, we would like to kindly ask you if you are interested in this work, and if so, trying to document it in an ID. So this is a very early stage of the work. So this is all from my side. We are happy to hear from you anything you want to ask.
Thank you very much, Sonia, for being also very on time. Unless I'm mistaken, I have not seen people raising hand to comments. I have one question, but I would like to give the floor to others first. Okay, if not, I understood from what you say about this aggregator that somehow this will be a kind of this contextual, I mean, the patterns that you describe, or the will be a bit like bottom up. I mean, it will be like organic. I mean, you will be observing what's going up from the network in terms of telemetry, and out of that, try to build a more aggregated model of our patterns. Is it a correct understanding?
No, the idea, if I understood you correct, the idea is more that you have a module in your system that all the sources that you have available, you can register once you know it, and then this module can send to the application needed by your system this information. For example, you have these three data sources, and the information that they can provide to you is this information, and this information. So by doing this, the application can select which is the information that really needs for working properly.
Okay, yeah, thanks for the explanation. I've seen also that in the chat there have been several comments and exchange on different aspects. So we will try to capture that also in the minutes of the meeting. And also from your last point about the interest from the research group and relaying Benoit's comments, yes, please document it. Even though I would prefer a data model instead of an information model. And data models provide APIs anyway. Data model versus IM is non-debate. So I think, at least personally, not as a chair, and I think from what I saw on the chat, there are some interest today to move further with this proposal, and it would be nice to get a bit more, I would say, materials to read from you. I think it could really benefit to other items we have in the research group on either the realm on AI related, or even maybe what Pedro just mentioned, which is needs for ontologies and semantic aspects of data. I think this could be benefiting a discussion in the research group. So yes, we will gladly be reading more from you on this topic.
Okay, thank you.
Pedro, you want to raise hand? Pedro? If you're trying to talk, Pedro, we cannot hear you. You're on mute.
Now, can you hear me now?
It's okay now.
Yeah, in fact, what I just wanted to point that the CIM model can be a good way to, let's say, implement the ontology that I was mentioning before. I was a few years ago, I worked with CIM, and it is quite complete for this task. So we can collaborate in these two topics together to put them together in the same place. Let's say the relation between the AI application and the CIM model for the for this information retrieval, etc. Okay. Yes. Let's talk in the future, please.
Okay.
Okay. Thanks for the presentation. Due also to time constraints, we will cut the line now and switch to the next presentation. So I think the next one is Milad. Let me just switch to the right slide set. You want to be able to present yourself, Milad? It's okay for me.
Is that possible that I present myself?
It's possible, but sometimes just for ending smoothly the transition, it's better if we do the slide. But if you have this, you can I can project and you can.
Yeah. The other thing is, like, I sent the latest version last night, and I sent you the latest version right now. Would it be possible? So it's not that much different, but if I could present the latest version, that would be great. But if it's not possible, that's totally fine.
Yeah, I apologize. Maybe just for the sake of time, because we're already running a bit late.
Yeah, of course.
Difference is not so critical. It will be better if we can handle it with the current version.
Sure.
Okay. So you have the control. You can click to go to the next slide.
Okay, sure. Perfect. Hi everyone. I'm Milad. I'm from University of Waterloo, and I present fault-tolerant service function chaining. It's joint work between me and my colleagues, Elijah Jalalpur, Professor Bert Wang, Professor Ali Mashdizadeh, and Professor Rauf Boutaba. So in this presentation, I will talk about fault-tolerant service function chaining. And the idea is that how we can keep a service function chain running after F number of its service functions fail. And I will talk about how we can integrate FTC, fault-tolerant chaining, with NSH to provide a fault tolerance for industry. Here's the outline of my presentation. Service functions or middle boxes are network functions that receive the traffic, process the traffic, and forward the traffic. Here are two examples. For example, on the left side, you see network address translators, and they act as a bridge between private network and public network. For example, in this figure, Alice and Bob are residing in the private network. They send the traffic and they use private IP addresses. And the NAT translates these private IP addresses to public IP addresses that are accessible in the internet. And change the header of the packets that it receives from Alice and Bob to public IP addresses and send the packet to the internet. In return, when it receives the packets back, it can replace the header with the private addresses and send it to correct address. On right side, there is another example firewall that receives packets and filter them based on some rules. For example, it receives blue and red packets, and based on the rules, it only allows blue packets to pass. Service functions fail, and their failing could be damaging. 43% of high severity incidents in data centers networks are due to failure of middle boxes. Even major players like Google and Amazon also have suffered from the failure of middle boxes. To combat this issue, there are fault-tolerant approaches, and the main idea behind fault-tolerant approaches is that we only need to replicate the state of that particular service function. For example, in this example, to make NAT fault-tolerant, we need to replicate its connection state. It uses this connection state to remember who is talking to whom. So for example, in here, the NAT remembers that Alice is talking to Apple, Bob is talking to Bing, and based on these connection states, it can translate the packets back and forth between private IP addresses and public IP addresses. So to make that fault tolerant, we have a replica, a NAT replica that exactly replicates that connection state, so that if the original NAT fails, and if we lose the original NAT connection state, we still have a replica of that. And the only thing that we need to do is redirect the traffic through the secondary NAT. But actually, the devil is in details, and there are main work that describe how we can achieve this replication. And they mainly focus on single middle boxes, single service functions, and they are a snapshot-based system. By snapshot, I mean that they frequently take the snapshot of the service function state and replicate it into some separate replicas, so that if the primary fails, we have the replica, a snapshot of the state in some other place in the network. Our work is to make a service function chain fault tolerant, and we, to the best of our knowledge, we are first to address this problem. But why is that different from make one? It is different from making individual middle boxes, individual service functions fault tolerant. It turns out if we use existing snapshot-based system for a chain of service function, the throughput drop is massive. On left side, you see that if we have a chain of 5 middle boxes, 5 service functions, we almost lose half of the throughput because of the snapshots. The reason that we use that much of throughput is that when one of service function is taking a snapshot, it has to pause its operation. But by pausing its operation, the entire chain stalls. And with longer chains, we have more pause time and no service time, and that's why we have a lot of throughput overhead. Our approach is different. We don't do a snapshot based, and we make the entire chain fault tolerant. The key here, the key difference is that we use the chain itself to make a service function chain fault tolerant. But how do we do that? I'm not going to go to, in the interest of time, to all the details about our system, but I will talk about two aspects of our system: state piggybacking and in-chain replication. If you don't mind, I first talk about in-chain replication, and then I come back to state piggybacking. So as I mentioned before, in existing approach to provide fault tolerance for a service function, what we need is that we replicate the state of service function in some separate replicas across the network. We wait for their acknowledgement, and then at that time, we can release any packet that has modified the state. But in our system, we use the chain itself to make the chain fault tolerant. We observe that already traffic goes through the chain from service function 1, service function 2 to service function 3, for example. So why not we use the subsequent service functions in the chain as the replica for for example, first service function. In this example, for example, we can use service function 2 as a replica of service function 1. When we combine in-chain replication with state piggybacking, and by state piggybacking, I mean that existing approach, we observe two traffic streams coming out of each service function. One is the data traffic, the normal traffic that they process, and the other traffic stream is to disseminate the state updates to replicas for state replication. In our approach, instead of doing that, whatever state has been changed to processing a packet, we piggyback that onto the packet itself, and there's only one traffic stream going to coming out of a service function. Combining a state piggybacking and in-chain replication gives us a system that can achieve high performance. So let's see in more details how our system works. So let's say that we want to provide fault tolerance for two service function, SF1 and SF2, and they're running in separate servers. To tolerate one failure, we instantiate three replicas, R1, R2, and R3, and they are they're located in separate servers in order to isolate their failures, so that if one of them fail, its failure is independent of the others. It doesn't cause the failure in other replicas. In here, the state of first service function is replicated by R1 and R2, and the state of the second service function is replicated by R2 and R3. Replica also intercepts packets, and they provide a state management API for service function so that they can trace and they can track whatever the state has been changed by service function, so that they can replicate it and send it to the next replica. As I mentioned before, whatever state has been changed by processing a packet, our system piggyback that onto the packet. So for example, in here, when the first packet comes to our system, the first replica sends it to the first service function and tracks whatever state has been changed due to processing that packet. And when the service function releases the packet, the first replica piggyback the state changes due to processing that packet onto that packet and releases the packet to the next replica in the chain. R2 receives that packet, replicates the state, detaches the piggyback the state, send it to the service function, track whatever state could be changed by processing that packet, and when service function 2 sends the packet out, it receives the packet, piggyback state changes into the packet, and send it to the third replica. And R3, when it receives the packet, it replicates the state, piggyback the state, strip that piggyback state from the packet, and then finally release the original packet to the outside world. By doing so, basically we achieve high performance. And here is one of the results that we achieved by running our system. We compared our system with non-fault tolerant service, with non-fault tolerant service function chain, which is basically the baseline, the highest performance that we can achieve. And we compared it with the state of art FTMB. You see two labels for FTMB, and FTMB plus a snapshot. You can ignore FTMB. FTMB plus a snapshot is actually the actual system. And as you can see, for a chain length, for different chain length, we achieve almost twice as the state of the art. And for the chain length of 5, we achieved 3.5 times higher throughput. We believe that FTC could provide a good platform for fault tolerance of service functions and service function chains. And combined with NSH, we believe that we can provide great platforms that is supported by, because NSH, which is a protocol designed by IETF, is already supported by industry. And we think that by combining NSH with FTC, we can provide a great platform for fault-tolerant service functions. Let's delve into the details of NSH. So network service header, or NSH, has been defined in RFC 8300. Yeah.
Just sorry to interrupt, but I think we are approaching to the end of your presentation time, and we're already a bit late. So if you have slides that you can maybe accelerate a bit upon, this will be nice.
Sure. So, yeah, it would be like 1 or 2 minutes.
Okay, thanks.
Yeah, sure. So we have, NSH has three main components: service function forwarder, service function, which is as before, and NSH packets. Service function forwarder can implement a replica, and the task that it does is basically, I cannot, oh yeah, okay, it's working. So SFF can replicate, can implement our replica. Currently, NSH supports packet forwarding through chain, but our contribution and our ongoing work is extending NSH for extending a service function forwarder to provide also state management API and state replication. And we add the support of NSH into click modular router. We also working on supporting NSH, using NSH header to piggyback state. NSH header, so here we see the NSH header, and there are lots of fields here, but the only thing that I want to focus here is variable length context header, which is the variable which allows us to carry, carry metadata inside service function chain, and we can use that to piggyback the state. I passed this one in the interest of time. Currently, NSH provides packet encapsulation and variable length metadata, but our contribution is we define how we can use NSH metadata to piggyback a state. And because these information are sensitive information about the network, we also need to devise secure approaches that maintains the confidentiality of the data. Thank you very much, and that was my presentation.
Thanks, Milad, for being straight to the point. Any comments from people? Okay, Jérôme?
Yes, thank you, Milad, for your presentation. I know we already had some talk, but can you give me, because I think it's very interesting, the idea of the piggybacking of the states. But what is, because you want to put in some in the NSH, what we can expect in terms of size that we need here to piggyback states for I mean, for certain service, if you have some example in mind?
Yeah. So for example, in our system, we implemented NAT. For NAT, usually one packet may cause adding some information into connection state, which is around 40 bytes. Load balancer also, stateful load balancer, they are around the same size, around 40 to 60 bytes. So lots of middle boxes, lots of service function. We expect that one packet shouldn't go beyond a few dozen bytes. And we think that NSH should be enough, NSH header should be enough to carry the state of one. But that's the question that you ask is very interesting, because for longer chains, when we have more service function and when we want to support higher failure, so for example, let's say that we want to support 5 failures. So we need to, packet needs to carry the state of 6 middle boxes, 6 service functions. For those cases, it could be challenging because it could grow too much. So there is a limitation there that we cannot go beyond some number of failures or beyond some size of service function chain, actually, function chain.
Okay, thank you.
Okay, thanks, Milad. I also raised a question on the chat, so maybe just for the sake of time, it's not need to process it now, but maybe offline by email or whatever we can discuss further about this. I think this is some also work you plan to probably propose towards SFC working group.
That would be our intention. Yeah.
Okay, so we will hear from you again, probably. Thanks, Mila. Sorry for being a bit, abrupt, because we are a lot of presentation and we like to take time to go through all of them. But of course, we can continue to discuss offline, as I say, on the mailing list or even direct emails. Thanks.
Thank you very much.
So let me just check what we have next on the agenda. So now we are switching a bit more towards the intent-based networking aspect of the research group activities. And the next one will be Luis for the transport slides intent.
Yeah, hello.
Give me just switch to the slide.
By the way, can you hear me well?
Yep.
Okay.
Okay, I'm showing the slides. Please let me know when they are up.
Okay, I can see them now. Yeah.
Okay, floor is yours.
Okay, thank you. Could you enter the presentation mode, because some of them are animated, but basically one of them, just to be sure that the animation run. Okay, thank you. So yeah, here we will present the slides intent approach that we have starting to document it in that you can see the reference. This is a joint work between Telefonica and Wings, and this has been initiated in the framework of one of these European projects, the 5G, and so we will provide details in the following slides. So next slide, please. Okay, so the background for this work is basically we started to explore these ideas of intent-based mechanisms, but applied to the network slicing concept. This, in fact, was already presented in the presentation that I referred there in the slides in the Singapore meeting. At that time, the work was basically focused on the location and instantiation and placement of different BNFs in some test facilities and so. And even though these BNFs are finally connected, there was not an emphasis on the transport slicing itself. Taking into account that there is some initiative in the TIS working group now, there is a number of people working on a design team. This is also my case, which is actually focused on transport slicing. So we tried to zoom in these ideas of being carried out in the 5G project, focused specifically on the transport part. So to see how we could apply basically this for requesting and instantiating transport slices. Next slide, please. Okay, thank you. So regarding this initiative in the TIS working group, there are actually currently two outcomes. One transport slice definition draft and another describing the framework for this transport slicing. But if we look at the first case in the transport slice definition, it is mentioned there that basically what is expected by the potential transport slice controller would be a way in the northbound interface, would be a way of expressing the need of connectivity in a technology agnostic way. So basically, we would not require at that stage in the northbound part to recognize any kind of complete configuration. So we could expect there a more declarative than imperative way of requesting the slices. So the request, just quote in the last sentence in the paragraph. So the request to instantiate a transport slice is represented with some indicators such as service level objectives. So no technologies are selected, and later on the technologies will be selected and managed accordingly once this is more or less processed. Okay. So looking at this, we thought that the intent-based approach could be adequate for the provision of these transport network slices. So as far as we could provide appropriate level of abstraction, we could manage, we think that we could manage this transport slice request with these intent-based mechanisms. And this is what basically we are exploring in this draft. Next slide, please. Okay, so for exploring that, we look at the case of the 5G services, which are basically the ones that will firstly require from the network operators the capability of instantiating network slices. In this sense, in the 3GPP, or the 3GPP defines a way of instantiating and requesting these slices end-to-end. So you can see in the figure, basically, it is expected to have a 3GPP management system that could manage it or control or associate it. The slices in the RAM part, in the radio access part, in the core network part, but also instruct the transport network management system to instantiate some slices and to connect the different slice parts or slice instances that could be deployed end-to-end. So basically here we are focusing on the yellow boxes. The transport network management system will be the one receiving the request for deploying the transport slice in the underlying supporting transport capabilities, either optics, IP, or whatever. So we will be here basically trying to address the interface between this 3GPP management system and the transport network management system. For the interface, I mean how to apply the interface mechanisms on this relationship between both management systems. Next slide, please. Well, looking at the concept definitions draft in NMRG, basically, intent is defined as a high-level declarative goal to define outcomes and high-level operational goals. Related to the 3GPP, to the 5G slice services and so, there is an initiative in GSMA where basically they are defining a generic slice template in order to allow users of the network, in this case vertical customers, to specify the different kind of attributes in order to deploy this slice end-to-end. And for those attributes, you can consider things like, for instance, the speed of the terminals or the location or whatever. But also there are some other attributes that are related to the transport part themselves, like the bandwidth, like the latency, and so on and so forth. So basically what we were looking at is that probably this generic slice template could be a very good foundation for these transport slice intents, in the sense that there would be a way of expressing attributes that the customer could fill out in order to request the properties of the slice to be accomplished in the transport part. Next slide, please. Yeah. So then, looking at the intent life cycle that is being defined in this concept definition draft from NMRG for the intent-based systems, basically, we see that there could be applicability of this generic slice template concept. And can you click, please, in the slide, because this is animated, just to. Okay. So here we do foresee that at this point there will be some processing of the generic slice template, at least in the transport concerns, in such a way that when the customer requests and fill. Control. When the customer, the vertical user, fill and request the transport slice, then there will be a process by the intent-based system in order to understand and to process the information of this slice template, and then apply them to the. Okay, I'm not sure. Okay, to the configuration of the network. So we will have somehow two processes here. So the processing and the understanding of the slice template attributes that could come from the generic slice template, and another process basically for instructing the network in this way, the transport slice controller, once these parameters has been processed and let's say that the request has been completely characterized. So we could expect at this level to manage the attributes like the ones in the generic slice template, and at this other stage, we could expect to Okay. To interact with the transport slice controller through the northbound interface. And here we reference another work that where we are trying to identify parameters that could be part of this northbound interface in the transport slice controller. So, moving forward, let's see. Okay. So regarding the mechanisms for translating the transport slice intents, so it's clear, or in our understanding, is clear that we need a well-defined context-aware attributes to be agreed upon. Sorry, apologies for. Okay. So with these context-aware attributes, there will be an unambiguous way of instantiating the transport slice through these intent-driven mechanisms. And these attributes will be basically a combination of a structured set of attributes that somehow could be communicated in an intent-based system on the upper layer system, the 3GPP in the example of 5G, but could be other examples, the other use cases, okay? Together with user input attributes that in such a way that we can complete all the intent base for the transport slice, and the intent-based system could check completeness and validity of the request and so. In translation approaches, what we are investigating now is basically the benefit of the natural language processing techniques. So we are considering that. This was also done in the initial work in the when we were referred to the network slices end-to-end. So we think that these natural language processing techniques could enable ways, let's say, of enabling this high-level expression of requirements could be missed and probably in an initial pass for once the attributes in the generic slice template are offered from the upper system. And also we will consider the support of artificial intelligence and machine learning mechanisms in order to support, let's say, the translation mechanisms and to make this learning process once we start running transport slices in the system. So this is intended work to be developed in the framework of this draft. So going to the very last slide, I think. If this reacts. Okay. So as next steps, so we will keep working on this, basically with these ideas of the natural language processing and so. Also, we will continue working on analyzing the attributes that are coming from the generic slice templates from but also others that are coming from the industry, and also from other use cases that could be the interconnection of NFV environments or network sharing situations or evolution of wholesale services and so. We want to keep this work aligned with the progress in this network slicing design team. So, trying to basically to complement the work being done there. And here we would like to basically request comments from the audience, from the group, from the research group, and inputs for new versions. We are in the process of preparing a new version. For sure, there will be a new version for Madrid meeting, but probably even before there will be some other versions. And just to reflect the fact that Jeff Tansura has joined us as co-author. So we are open for contributions, and we expect that this could have interest for the research group. And that's all from my side. Thank you.
Thanks, Luis. Let me just check the chat because the window is closed.
I just have one question, if I may. I'm just wondering, in terms of your attributes at the intent for the transport slice layer, do you envisage that the attributes would be delay, jitter, etc., or would the attribute be a more a higher level declarative in terms of who needs this kind of slice? For example, is it EMBB? Is it sliced for EMBB? Is it sliced for some of the specific types for 3GPP service types? Thank you.
You're welcome. So there could be probably a combination of both of them. So there would be something that could be more or less straightforward translated to transport requirements, like throughput, which basically can be translated to bandwidth or latency and so. And there will be other attributes that are not directly, are indirectly impacting the transport network. For instance, availability or reliability. This maybe could make the transport network to create some protecting paths in order to accomplish a given reliability. Or even if the slice template declares the need of deploying a service in a given location, so indirectly you can infer the needs of having transport capabilities in that area, in that geographical area, and so there could be probably a mix of both of them. So what we are doing in one of the works that I refer there, the Draft Contreras piece, MBI, is trying to digest how these attributes could impact directly or indirectly in the transport part. So there is a parallel ongoing work on this direction. So I invite you to check and document if you wish.
Thanks. So you envisage that it would be more like specific requirements, not high-level requirements saying give me the slice for this application, and then that the transport layer understands the requirements in terms of bandwidth and delay and jitter from higher level abstraction.
Let me insist that our starting point is to take the generic slice template from GSMA or the NEST, the equivalent in 3GPP. There we have attributes that really impact the network, like throughput. So this is we don't need to infer so much on that, because if the slice need to support 100G, so we need to provide 100G. But there will be another attribute that probably will be more generic and required to be processed. Like the example I mentioned before about reliability. So if you need to guarantee 99.99% of service availability, then probably I need to instantiate different paths in the transport part in order to guarantee such level of availability. So there could be probably a mix of them. For a starting point, let me remark this is the generic slice template. So we are starting from that. Going at higher level like AMBB or URLC and so probably is not enough, but we need something else to step. I mean, you need some kind of attributes, and our starting point is the GST, and we are working from that. Not sure if I'm able to fully address your question. If not, we can talk offline.
Yeah, thanks. Thank you very much.
Okay, I see that Eric raised hands and asked a question. Eric?
Yeah, sorry, I had to mute myself. So just as a clarification, and just to expand on what Lewis was saying, the intent in the work that's going on right now is that the transport network doesn't understand the actual applications that are applying for a transport slice. So the intent would not include any information about exactly what this slice is used for. It's just information about what the characterizations are, or the attributes, as Luis says, that are to be communicated to the transport system.
Yes, that's the point. Yeah. Yeah, that's the point. Yes.
Okay. So I don't know if Eric was okay for you, but since we're also running a bit late with respect to the initial agenda, I would like to close the discussion now. I think it's new internet draft that we have for the group. I think there are interesting points to be further developed and some interaction, as we have seen with other members of the group. So I hope that this will continue on the mailing list or before the next virtual or in-person meetings. And so we'll have, I think, more time to investigate some of those points further. And I would like to switch to the next presentation, please. Okay, thanks, Luis, for the presentation and the input to the group.
Thank you.
Our next presentation will be Navid on automated design of network services from network service requirements. And so as we are running late, if you can be quite to the point, this will be appreciated. Let me just bring up the slides.
Hi. Yes, sure.
Okay, floor is yours.
Thank you. I'm not seeing it yet. Yes, here it is. Okay. Hello, everyone. My name is Navid, and my presentation today is on the project Automated Design of Network Services from Network Service Requirements. And this project was a research project in Concordia University in Montreal, and it is in collaboration with Ericsson, and it's supervised by Dr. Farah Kendek and Dr. Maria Toro from Ericsson. Next slide, please. So my outline will be a quick background, then the motivation and the goal of the project, an overall picture of our method, and after that, talking about the modeling framework that we have, and then discussing the method steps and the prototype tool that we have designed, developed, and finally conclude in the future. Next slide, please. So as a quick background, so a network service is an interconnection of network functions that provide a composite functionality or behavior as a general concept. Network function is a functional block in a network with defined functionality and external interfaces. So as I hope you all are familiar with NFV system, network function virtualization, network functions and network services can be deployed in network NFV system. And one of the main management blocks in NFV system is NFV, Management and Orchestration, or MANO. MANO requires a deployment template for a network service in order to deploy a network service in the NFV system. And that template is called Network Service Descriptor, which describes the network service from a virtualization aspect. Next slide, please. So NSC generation requires designing the desired network service to begin with. And the design process is the process of selecting proper network functions and arranging them together to achieve the composite functionality and behavior. This is out of the scope of NFV, and it is done manually by experts today. The issue with that is NS design process is knowledge extensive, meaning many different tenants might want different types of network services for different domains, and that's really knowledge extensive to design. And manual NSD generation is also error-prone because of the many details in NSDs. And in general, that doesn't fit in telecom zero-touch vision. So automation of NSD and NSD design is desirable, is highly desirable. Next. So the goal of our project is to devise a method for automatic network service design that fulfills the tenant's intents, whether high level or low level. Those intents, or basically network service requirements, we call them NSREQ. The main goal is to generate, and then after designing the NS, is to generate the NSDs according to the ETSI's NFV standards to be used by NFV manual for NS management and orchestration. And our methodology is a model-driven approach because of the direction of ETSI and leveraging their models. Next slide, please. So the overall picture of our method starts from the tenant providing us with the intent, and the output goal is the NSD, standard NSD, but there is a huge gap in between because the intents are high level and the NSD is at the low level. Next slide, please. So we fill this gap with our method. So we take the intents or the NSREQ from the tenant and we map it to a knowledge base, which we call network function ontology. It has the knowledge of network function decompositions and all the architectural information for network service design. So we decompose our NSREQ to lower level information, and then based on that, we select appropriate DNFs from a catalog. And then we generate forwarding graphs according to those knowledge. And then finally, we generate NSDs that can be used by NFV manual. Next slide, please. Thank you. So as I said, our approach is model driven. So we have a modeling framework, and the basis of it starts from this picture. Every network function from two different aspects. One is functional, and the other is architectural. From a functional perspective, a network function is a functionality, provides a functionality. And from an architectural perspective, from a more concrete point of view, that functionality can be realized by a more concrete element, like an architectural block, as we call it. And for instance, an architectural block defines the interfaces and the protocols used to realize that functionality. And our assumption is, I mean, based on our definition, the real implementation out there, like VNFs and PNFs, the virtual network functions and physical network functions are implementations according to those architectural blocks. Next slide, please. So keeping that basis in mind, I start from introducing the NSREG model. I start from an example. Let's consider a tenant requires a VoLTE service with voice call and registration functionalities, and 6 megabit per second throughput for voice call and 50 registrations per second. And the constraint is using IMS architecture. So the way we model it is shown in this picture. You can see the VoLTE decomposed to voice call and registration, and you can see the non-functional requirements attached to them, 6 megabit per second, the throughput and the request per second, and the architectural constraints. So that's the way we model. And if you go to the next slide, I can show the overall picture of the meta model. So here is an overview of the NSREG meta model. NSREG meta model consists of functional requirements, architectural requirements, and non-functional requirements. As you can see, functional requirements can be decomposed to lower-level functional requirements, and other blocks can be attached to each functional requirement. And here you can see a small overview of the meta model, which we use UML and profiling methodology in UML to model our meta models. Next slide, please. So next up is the ontology, the knowledge base that we capture knowledge into. The ontology structure is quite similar to the NSREG meta model, but it consists of more details and more information. So the first picture you see is an overview of our meta model. Ontology meta model consists of functionalities and their decomposition to lower-level functionalities, and on the other side, architectural blocks and their different decompositions. And these decompositions can be captured from standards and different research papers or any knowledge out there. An expert can enrich this ontology. And here at the bottom, you can see a picture of an instance of this ontology. So you can see a VoLTE with its complete decomposition to lower level functionalities like messaging, voice call, authentication, registration, user for storage. And on the left side, you can see the architecture of an IMS system. And you can see the relation and how those functionalities can be realized by these IMS blocks. And that's how we capture the knowledge of functional decomposition in general network service design. Next slide, please. Here, quickly, I discussed the VNF virtual network functions information models as well. So VNFs are standardized by ETSI, and they provide the meta model for those information elements, including VNF descriptor and some other artifacts. But those are all virtualization, provide information from the aspect of virtualization perspective. So, but for NS design, we need application perspective information. So we have proposed an extension to these VNF information elements, and we call it VNF architecture descriptor. That VNF architecture descriptor provides us with the information about VNF functionality, VNF components functionalities, and VNF application interfaces. And we assume that this VNF architecture descriptor is also provided from the vendor. So we capture all this information and we put them in a catalog. Next slide, please. So I talked about those three main information elements that we use as our inputs. And here, that's how we process them. So the first step, we generate a solution map model. We initialize a solution map model. It's an intermediary model that captures all the information throughout the NSD generation process. In step two, we have, to begin with, we have the information from the NSREC into the solution map. So in step two, we map the solution map to the ontology, and we traverse ontology. We capture the subtrees on the functional side and architectural side that matches those requirements, and we capture them, put them into our solution map. In the third step, we take those captured architectural blocks and we go look through our VNF catalog, and we select the proper VNFs matching those architectural blocks, and we bring them and put them in our solution map in relation with architectural blocks. Next slide, please. Then after that, now we have all the information that we need from the ontology, but we need to separate alternative solutions, because you can see that we have multiple levels and layers of decomposition. So in three sub-steps, we separate those alternative solutions. First, we look at the functional decomposition, and we generate functional forwarding graphs. Those are sequences of functionalities that each of them, all of its functionalities together, can compose the root functionality that is desired for the network service. So after generating all possible forwarding graphs, from each of them we generate architectural forwarding graphs, which is a sequence of architectural blocks that realizes those functionalities. And after that, with the same token, we generate pre-VNFFGs, which is basically VNF forwarding graphs, but without networking elements like mutual links and the detailed flows. So each pre-VNFFG is basically a combination of VNF forwarding, a combination of VNFs that can altogether compose the desired network service. Next slide, please. So, as I said, each pre-VNFFG can be a potential solution. So for each pre-VNFFG, we generate a generic network service descriptor because it has all the VNFs that can compose the network service. And I call it generic because they are just with respect to functionality and architecture, just composition of architectural blocks, not the networking part and not the virtual ones. So in this part, in this step, we generate the virtual, we design the virtual links, we design the service access points, and we generate the descriptors. And we generate the VNF forwarding graph descriptors as well. We have a step to also enrich our ontology if the NSD generation was successful so far. So we take new information coming from the NSREC and we try to enrich our ontology. Next slide, please. So this is the final step of our method. So in this step, we take the non-functional requirements into account. If you remember, in my example, I showed like throughput or requests per second, those kind of requirements. So, but first, we design the flows. We design the flows according to the tenant requirements, wherever he or she has requested for specific load on some functionalities. So according to those, we design different flows, packet flows, and we use dependencies between the VNFs and using the internal flows of VNFs, which those information have been captured so far. We design the flows, and then we take those non-functional requirements and we propagate them throughout these flows to anticipate the load that are supposed to be exposed on each VNF. Therefore, we are able to dimension each VNF by anticipating that load. So by considering that load and the deployment flavors of each VNF, we dimension the VNFs and we tailor the deployment flavor of the network service. And that's the endpoint of our method. So at this point, we have designed the network service descriptor, which we have anticipated the load for the VNFs, and we have dimensioned them, and we have tailored the DNF, the network service descriptor. Next slide, please. So we have developed the prototype tool as a proof of concept. As I mentioned, our methodology is model-driven. We use Atlas transformation language, and we use UML profiling to basically provide our meta models, to create our meta models, and use Papyrus environment to generate our models, UML models. And the use case that we had previously was multi-service using Iris architecture. The next slide would be my conclusion slide. So far we have proposed a method to automatically design network services based on network service requirements or the intents for the network services that tenants have. By decomposing those intents using the knowledge base and then selecting the suitable units from a catalog accordingly, and then design the forwarding graphs. And based on that design, generated all possible NSDs that can be used by Nano and refine those NSDs according to non-function. As a future work right now, we are working on validating our method further with several case studies, specifically with 3GPP mission critical system. And also another parallel work we are working on in the group, but it's being done by another person, is on with the same concept, but designing network slices, automatic network slice design, which is the same principle, but with more details and more features. So thank you very much for listening, and I'm more happy to answer your questions.
Thanks a lot, Navid, and to be very on the point concerning time. I see that Chin has a question on the chat. You may raise it vocally if you like, please.
Yeah, how DNF architecture descriptor is different from NSD. The end goal seems to generate NSD. Yes, so well, a VNF is a virtual network function, and a network service is a composition of VNFs. First, this VNF architecture descriptor is a descriptor for that VNF, but the NSD is a descriptor for the network service, which is a higher level, more composite element. Other than that, also, VNF architecture descriptor is our extension. It consists of information regarding application aspect of that VNF. In opposed to descriptors, which Etsy provides, those are just virtualization aspect elements, meaning they just provide information regarding what's the structure of this, let's say, VNF as a virtualized element. For instance, what are its components inside, how they are configured together, how they are connected together through virtual links, what are their external connection points, but they don't talk about their functionalities. They don't talk about their, for instance, APIs, which are regarding the functionalities. So this VNF architecture descriptor captures those architectural aspect information opposed to the descriptors. I hope if I was able to answer your question, please let me know.
Okay. Jérôme also is willing to make a comment.
Yes. Just a question regarding the description of requirements for network service. Is there, in your approach and in your work, is there a way to have requirements that have some dependency in a way that, not all requirements must need to be fulfilled at the same time. It can be a combination of requirements and some exception, or let's say alternative requirements. Is there a way to define such kind of things or not?
By that you mean, for instance, I'm just clarifying myself for understanding your question. So you mean in the requirements, we have multiple different types of requirements, and how we capture them all together, or how we resolve the contradictions. Is that right?
Yeah, but basically, if you have some requirements that are alternative, like you imagine you have some logic between requirements, like or usually requirements are just kind of conditions that all need to be fulfilled, but some kind of may have more complex requirement for certain service, I suppose.
Yes. Well, so the requirements that we get, we match them to the ontology, and therefore we start from the high-level requirements and traverse down, and every time we reach one of those blocks of requirement, we try to match them to our ontology, because we rely on the knowledge provided from the ontology. So any requirement that is in contradiction to the ontology, for instance, let's say there is a composition or there is a dependency that the complete opposite of it is provided in the ontology. We neglect that requirement and we stick to the ontology because we assume that tenants might not provide us with a fully compatible requirement. So we stick to the ontology basically, and we resolve those requirements by taking from the knowledge from the ontology. That gives us the information within the requirements.
Yes, yes, okay, yeah,
okay.
That's good. Thank you.
Thank you.
Okay, so if there are no further questions, we will move to the next presentation. Thanks, Navid, for this interesting work. And I think we will get in touch for the next steps. Thank you. So our next one should be Julian on intent classification.
Okay, can you hear me?
Yes. Let me just bring up the slide. Okay, the floor is yours.
Sorry, I didn't say anything.
Can anybody see the slide or not?
Yes, I can see it.
Yes.
Yes.
Ryan, for you, it's okay?
Yes, okay. Hello, everyone. My name is Sun Xueyuan from China Telecom. Next, let me introduce the draft of intent classification. The next slide, please. Excuse me?
I'm on slide 2.
There was some delay, but now it's slide 2.
Okay. The goal of this draft is to bring clarity to what an intent represents for different stakeholders by means of classification on various dimensions, such as solutions, users, and intent types. This classification would ensure a common understanding across all participants, and it can be used to identify the scope and the priorities of individual projects, POCs, research or open source projects. This is achieved by proposing initial classification tables and the methodology used for generating them. This methodology can be used to update the tables by adding or removing different solutions, users, or intent types in order to cater for future scenarios, applications, or domains. This draft, together with draft IETF, NMRG, and BN concepts definitions, aims to become the foundation for future intent-related topic discussions, where all participants have the same common understanding. Next, please. Since the update of the draft version 2 in November 2019, we have received the support of experts and suggestions for improvement to the draft. The following is a summary of all the comments we received offline and online, and address the corresponding solutions one by one. Like the comment expressed by Jürgen that alignment with the draft climate NMRG is the intent 3. We addressed by updating the draft and referring in the introduction to climb and explaining what the scope of each draft. Jerome and Laurent commented that the value of the document and the tables not clearly explained. As well, Branislav Miazea commented that intent abstraction should be formal. Therefore, we addressed by updating the introduction section and the discussions on the mailing list, as well as explaining in the introduction the purpose of this draft and that is not planned to be a formal definition of intent. Yahya Al-Khatib said on the mailing list that it is not clear what is the difference between intent and policy in our draft, and we addressed by updating the introduction and referencing claim draft that describes the differences between service, policy, and intent. As well, we updated the section 4 and the subsections 4.3, 4, 5, and 6 by making them intent and not policy focused. Similarly, we also have received some suggestions such as Jerome and Laurent suggested that our draft should present intent methodology, and we adopted by adding a new subsection 5.1 and 5.2. Jerome also advised that it would be better if we could have some concrete examples of intents from different perspectives. In response to this suggestion, we have added examples to the tables in section 5.1, 5.3.1, 5.4.1, and 5.5.1. Natalie Bob commented that it is unclear what is the scope of the policy continuum section in this draft. Thus, we have removed the section in the draft. In summary, we updated the draft to version 3 as follows. In section 1, we updated the introduction to clarify the scope of the draft. In section 4, we updated section 4 to make it more intent and not policy focused. And in section 5, we added the intent classification methodology and examples for the intent tabs. And in section 6, we removed the policy continuum section. Okay, next slide, please. For ease of viewing, the place marked in red are the major changes of this draft. It can be seen that in section 4, we have made many changes compared to the previous version, such as adding new subsections about intent scope and intent network scope, and modifying the content of the original subsections about intent abstraction and the life cycle, and adjusting the logical relationships between each subsections. Next, I will detail the updated content of each part. Next, please. First of all, in section 5, we added the intent classification methodology as shown on the right. The proposed methodology can be used to create new intent classifications from scratch by analyzing the solution knowledge, as well to update existing classification tables by adding or removing different solutions, users, or intent tabs in order to cater for future scenarios, applications, or domains. We first to classify intents into intent types and describe each type based on the solution it belongs to and what intent user it is for. We then present different categories that this intent type can belong to based on intent scope, network scope, intent abstraction, and life cycle. In the above methodology, the all arrows means the following. Input represents the solution knowledge comparison of knowledge about solution requirements, target use cases, available technologies and networks, actors, intent requirements. And the RX, UX arrows mean reviewing the existing classification and use, add, remove the intent solution, user types, intent types, and etc. Okay, next, please. In addition, we have added intent examples for all intent types in all the tables in section 5.3.1 and 4.1 and 5.1. The picture on the right is snippet from carrier solution table in section 5.3.1. For example, for a network operator, when the intent type is network or service intent, the operations that may be desired is request network service with delay guarantee for access custom A. Okay, next slide, please. And in section 4, we updated this section to make it more intent and not policy focused. We newly added 4.3 and 4.4 subsections and updated 4.5 and 4.6 subsections. In subsection 4.3, we defined the scope of the intent. The intent are used to manage the behavior of the networks they are applied to, and all intents are applied within a specific scope such as connectivity, security, application, and QoS scope. And in subsection 4.4, regardless of the intent user type, their intent request is affecting the network or network components, which are representing the intent targets. Thus, intent network scope can represent VNFs or PNFs, physical network elements, campus networks, SD-WAN networks, and the cloud edge, cloud core, branch, and so on. The next slide, please. Furthermore, we updated 5.5, renamed as intent abstraction to focus on characteristics of feedback of intent. And the intent can be classified by whether it is necessary to feedback technical network information or non-technical information to the intended proponent after the intent is executed. As well, intent abstraction covers the level of technical details in the intent itself. And we also update 4.6 intent lifecycle as renamed the intent lifecycle to classify intent into transcendent and persistent. If the intent is transcendent, it has no lifecycle management as soon as the specified operation is successfully carried out. The intent is finished and can no longer affect the target object. If the intent is persistent, it has life cycle management. Once the intent is successfully activated and deployed, the system will keep all relevant intents active until they are deactivated or removed. The next slide, please. In section 1, we have updated the introduction to better explain the need of intent classification and acknowledge claim draft for defining different intent concepts and terminology. CLAM is currently leading these efforts by defining intent at higher level, The clarity or more positive that operates at the level of network and the services it provides. However, even with proposed intent concepts and terminology and agreement on common intent characteristics, an intent may still be viewed in different ways by different stakeholders for different use cases and solutions. Thus, the goal of this draft is to bring clarity to what an intent represents for different stakeholders by means of classification on various dimensions. The classification would ensure a common understanding across all participants, and it can be used to identify the scope and the priorities of individual projects, POCs, research, or open source projects. This draft, together with CLIMB, aims to become the foundation for future intent-related topic discussions, where all participants have the same common understanding. Okay, the next slide, please. In conclusion, the current version has addressed all the comments received online and offline. And furthermore, we want to ask for adoption as a research group draft seriously. Regarding the next step of this draft, we summarize the following work plans. First, add a section briefly describing intent work status related to intent classification and taxonomy in other SDOs, such as the 3GPP and ETSA and MEF. And we keep the draft aligned with the draft IETF NMRG IBN concepts definitions. What's more, work with the community to derive unified intent definition that encompasses all intent types for all solutions and intent users. At last, improve the draft further based on any new comments. The above are all introductions to this draft update. That's all. Thank you for listening.
And we will check on the chat. There are comments or questions on the presentation.
Okay, maybe Jérôme speaking as a chair regarding your last slide. So first of all, thank you for your very hard work to improve the document and answer different questions. Regarding the process, one of the suggestions I would like to give to you maybe is first to publish the release version as a version 3 of the individual draft. I think that will be the first step. And then before going for asking for the adoption, my advice will be first to go for a very short round of comments regarding this version 3 on the mailing list, like 2 weeks, in particular from people having a comment on the previous version, to see if they are satisfied with how you address the comment. And then after this check, if everything is fine, maybe the code we maybe ask for adoption officially for the document. That will be my advice as a chair. To be sure that before you ask for adoption, which will be somehow enter into, let's say, official process, the comments you receive from people who have previously made this comment are okay with on the manner you modify the document. But of course, do not forget to first publish the version 3 of the document. I know you send it on the mailing list, but please upload on the data tracker that is fully shared and into the document of the group. Will that be okay with you?
Can I just give a comment, Jerome? Like, I think, thank you very much for your suggestion also, but I just wanted to say in regards to the comments to engage the comment authors, I think just to remind that we went through the extensive phase of emails and PowerPoints with all the comments and asking the comment authors for their for their conclusions and for their feedbacks in regards to how we want to address the comments. So I just wanted to remind you about that, that we went probably, I would say, a month of exchanges and discussions, but I do believe it is better to do it with the version 3. So thank you very much. We will repeat the process, but I just want to remind that we tried to do that already, and we had PowerPoints with all the comments and asked for people to reply, but we didn't get replies from everybody.
Okay, I understand your point. So as in a role of co-chair, if you publish this as version 3, we will also push a bit on the mailing list, so that people, including me as a personal as well, reply on your document and how you have addressed the comments, to give you the feedback in a relative short period of time, like as I said, 2 or 3 weeks maximum. Also to support this work, because I think it's good. You made a lot of very concrete modification to the document. But yeah, for me, it's if you go in this way, it's better than before you go into the process of adoption, and then you have to wait and maybe a bit more. It will be sure that at least you have more chance to have the document then adopted in the group. It just kind of for the sake of checking that the way you address the document is aligned with the document you receive. There are no misunderstandings. But of course, as chair, we can push a bit on the mailing list that you receive comments and as well. That okay?
Any further comments concerning the next step for this draft? What we could do also, because we already had the first call for research group adoption in December for this draft, and after that there have been only the group behind the scene and by the authors and other involved participants. So maybe we could clarify by to the list of the discussion today, what we have seen in the slide presented today, our recommendation as chairs for publication of V03 to be the new baseline, and ask for comments for a period of 2 weeks. And then at the conclusion of this period, to be able to restart a new call for adoption. So if you can clarify this by email, I think it will make a good point on the mailing list with respect to the previous call.
Yes, agree.
Okay, thanks, Julian, for the presentation. I know it's already quite late also for our participants in Asia. So we will move on. I think the next slide is, it should be Benoit for an update on the service assurance for intent-based architecture. Just grab the right slide set. Here we go.
All right, so in this 15 minutes, I want to present 2 drafts that have been presented to the OPS-WG. But as you were mentioning, Laurent, at the beginning, they're highly relevant to NMRG. So the 2 drafts are mentioned there. The things that I want to mention first is that we believe we addressed most of the feedback received in NMRG last time, verbally or many verbally during the research group session, and also the feedback received from the OPS-WG. The second thing is that you would see from the list of authors who've been working with many operators, and I see Paolo and Diego on the list here. So much feedback addressed there. So next slide, please. The issue we're having is that, yes, we've got Yang, yes, we could configure networks, but the fact is that we all know it. We've got like a service configure, but it doesn't mean that it's operating correctly. There could be many issues there. Now we're telling, okay, we're going to send telemetry, but we see it coming. We've got like way too much telemetry. This is the issue of the needle in the haystack, right? Now, whenever a service degrades, the thing is any knock wants to discover where the fault is. And by this, I mean, there are easy ones like, okay, there is the root cause, interface is down, for example. Great, we know it almost directly. But whenever we've got like symptoms, it gets like most difficult. If it's A and B and sometimes C, then we have the symptoms to know what's happening. The other issue we're trying to solve is that, okay, now I've got like a component that fails, let's say an optic, or fails or degrades. Now, which services are impacted? This is also key to understand. Now, we have to understand as well, the first step is like closed loop automation. This is what we're trying to solve here. The next slide, please. However, we know that the end goal, this is like intent-based networking. But it's like a pyramid of needs, right? You're able to do configuration, then you've got operational data with telemetry, then you close the loop. Then whenever you close the loop, you could potentially go to self-start, to intent-based, right? And this is what we're trying to do, trying to decompose this from bottom up and trying to decompose this into smaller components, what we call a subservice. Then we've got an assurance graph that is going to link those subservices. And we're going to map it to the service intent. I'm going to show you how we do it. Then the idea would be to assure all these subservices independently, right? I mean, it's a fact that we all collect like the interface counters. But okay, so what? To have a nice graph, it would be way better to understand if the interface behaves correctly. Right? Then we would have like a health score for the interface health. Now, because you got the assurance graph, we could bubble up the inferred health score of the service. And I want to stress inferred, right? Because this architecture complements the end-to-end active probing. Where we're going to get like the real packet loss and delay and jitter and all this. So whenever you've got those two solutions, then we start to have a good architecture. Next slide, please. So if I take a very simple, the simplest service you could have, like a tunnel, right? We take a tunnel instance. And then if we look at the dependency tree, the assurance graph, we want to have the tunnels to be healthy. We want to have on the left-hand side, the tunnel interface peer 1 being healthy, as well as the peer 2 being the destination. And those two rely on the health of the physical interface, right? And then they rely on the health of the device. You know, it would be way easier if you would have like a device and the ability to say, this device is healthy. So if you look for a problem, this is not where the problem is. And on the right side, the tunnel service instance also depends on the IP connectivity between A to B, or peer 1, peer 2. That also depends on a control plane, in this case, ISIS. So we've got the source at the top and the subservices, the subservice instances at the bottom. All right, next. And I think you went one too far. One slide before, please. Oh yeah, that's one, yes. So then what we could be doing there is, as I mentioned, if we know that the interface is like unhealthy, an optic is bad, is degraded, right? We have the health of that interface, of that optic, sorry. And then we could just say, well, obviously, because you got the assurance graph, this specific tunnel service instance is affected. So I could infer the health of a tunnel service instance by looking at the health of the components in the tree, the assurance graph. And now the next slide. I want to show that there are two different types of dependencies, right? Obviously, if I got like an interface being down, that's obvious that my tunnel will be down. It's what we call an impacting dependency, right? This is the root cause, we know it. And on the next slide, we've got like typically an informational dependency, meaning I've got this tunnel service, but it goes over 4 ECMP paths, right? One of them is down. Is my service impacted, yes or no? Maybe yes, maybe no, right? But the point is that I want to be aware of that symptom. And this is what we mentioned by informational dependency here. Because that symptom combined with a different symptoms, let's say I see a packet distribution change in interface, and I see an ECMP issue, for example, because there is like a bad load balancing, we might find a correlation between those two events. All right, on the next slide, trying to summarize what we've seen so far. When a service degrades, we could discover what the fault is, whether this is a symptom or a root cause. But most of the time, the most interesting ones are the symptoms, because the root cause are easy. And then we know also that whenever a component fails, I was mentioning the optic, then we know which service instances are impacted. All right, next please. I want to show here that trying to standardize something here is like trying to standardize an architecture, sorry. And we try to do it for multi-vendor. It has to be, because there are not many networks in the world that are only single vendor. And we did it with a Yang module. It was somehow my feedback to one of the previous draft. That was Yang, we could deduce, we could generate APIs. And this architecture is flexible in terms of components. I will show you that. In terms of service and subservices. So we could be adding new subservices as we see them, right? If someone needs multicast, we could add a multicast subservice and expand the assurance graph. It's also flexible and open in terms of distributed graphs, because we see it coming. Different controllers could have part of the graphs, or even like in routers, you could have part of the graphs. And to refer to one of the previous presentation, it works for physical and virtual. So next, please. So this is the architecture. So we get the intent from the service configuration orchestrator. We get like the service ID, the service config, and then we extract the intent of that service. We create the assurance graph that goes into some SANE agent. And then we collect the required metric via telemetry, and we send the health score and the symptoms of all of those subservices along with this assurance graph. And then we have all information that we need to potentially close the loop. And the value of this is that it's all model-based. So both the config and telemetry, so we're comparing apples to apples. In the next slides, I want to show that basically it's flexible in terms of components. We could have like the SANE agent in router that switches, and we could have like the orchestrator and the SANE orchestrator both into a single box. The point in the next slide is that what we want to do is to have this open architecture monitor. So we want to specify the interfaces. So this is where we've got the arrows with Yang, and they want to be open, so they are there with a Yang module. However, in the next slides, what we don't want to do is we don't want to standardize an orchestrator or an agent. Basically, this is software, right? It would be like forcing a specification of an implementation. It's way better to have like the APIs. All right. Now, next slide, please. If I look at the Yang models here very quickly, right? I don't want to go into details of Yang, but we have modeled dependency relationship by telling impacting informational. On the next slide, we have also modeled the health score and the symptoms per subservice. In the next slides, we've been adding a maintenance window. Typically, I mean, if you're upgrading a device, or if you're replacing this bad optic, or if you're doing a routing protocol adjustment, you don't want to receive any symptoms from that specific subservice. So you could just disable receiving symptoms there. All right, in the next slides. One of the new additions is that we've been adding like a Yang module for the assurance of the interface. And somehow it shows like if you're assuring a device, you've got the device ID as a parameter. If you are assuring an interface, you are assuring, you need two parameters, a device ID and interface ID. And we showed how we could extend this, even with some vendor-specific subservices, right? In my first slide, for example, if I've got like a Nokia, Huawei, or Juniper device, I should be the one having the device health. All right, and I think you'll be happy, Laurent. My next slide is the last one. Something that needs to be improved. This is I need to align the draft better with the NMRG concept and definition. Now, the feedback I've been asking is like, is this a valid problem to solve at the IETF? And now we're going in the right direction. And then I asked that question to the OPS-WG. It was for group adoption. However, the feedback of this group is that I would like to get the feedback to make sure that all the concept definition that we're going the right discussion according to what's discussed in the research. So thank you.
Thank you, Benoit. I think on the chat we have at least Louis raising in. Louis, you may need to unmute. We cannot hear you.
Apologies. Yeah, my question is for Benoit is: do you intend also to work in the standardization of these sub-services, or is just do you plan just to stay on the model, the overall model? I mean.
So that's a very good question, and I believe the answer is yes and no. Yes, because there are some of them that should be standardized. I'm thinking, you know, as I mentioned, we all monitoring like the interface counters, and whatever router vendor you have, trying to get like the health of an interface should be then the standard. This is not where the value is, right? The value is higher in the stack. So some of them, yes. For protocols, I was mentioning ASIS on purpose, right? Or segment routing or Spring. What if we would be thinking directly about the assurance whenever we're developing a protocol? I could envision having a couple of subservice assurance Yang model, like interface, like for some protocol. We've got the knowledge in the IETF, and as I said, this is not where the value is for all the vendors. Makes sense?
We have Alex.
Yes, hello, this is Alex. I have a quick question because one thing that made me curious is actually looking at your tree view and your Yang module. You expect to maintain all the dependencies as configured information. One question that I would have regarding the practicality of this, because presumably you're going to have a lot of interdependencies between a lot of objects. So do you have any comments on that? How you these relationships, a lot of dependencies, a lot of which may be highly dynamic and so forth.
That's right. I mean, you are fully right. So this will be a complex graph. So we could stay at different levels. You could just stay at what was configured. As you know, getting like the health of the IP connectivity that was mentioning in a slide, whatever. Just trying to get that and potentially trying to see where it goes. It goes from A to Z, going from B, C, D, etc. Or ECMP. ECMP is dynamic, right? Per definition. Right. I mean, if we could just solve the ECMP issue, that would be great. So yes, there is a lot of dynamicity in there. We've been experimenting with code, and this is what we're focusing on. And yes, it will be a huge graph. It could be as huge as you want. We're selling this also in the virtual world up north. Now, yep, you're right. There is a lot of interdependencies there. Thanks, Alex.
Okay, I think we have also Torres in the line.
Thanks, Benoit. Can you go back to the architecture picture?
Slide 11. Yep.
Is it the one you want to see?
Yeah. So I think the one of the interesting question to me is, to run through some example of workflows, right? I think that's some amount of work that would be good to understand what could be gotten out of this. So, for example, the way I kind of imagine how this ultimately works is that I have different levels of abstraction, right? What comes from the service configuration orchestrators, more high level, and then when it goes further down, then I've got some lower level, like let's say existing Yang-based configuration of individual network elements. And the way I see it, what would be lovely is to have a way of attaching one level to the other through references, so that when I look at configuration of a router, I'll be able to see which of the services are requiring a particular configuration, or vice versa, when I basically want to do some inventory management or something like that, that at the service level I can see what network components or configurations are there. So that mutual referencing, I'm not seeing this expressed, but that would ultimately, I guess, be something that the orchestrator might need to do. What's your thought on this?
Right, so you're right in that sense, right? So basically, we take a service model on top of an orchestrator, then we configure something device. There are two different choices: either it's a CLI or it's a Yang. Right? If it's Yang, then we have a server solution because we already have the Yang models that we need for config, and then based on that, we could try to find a mapping. And it's easier if you start from Yang models. Case number two is that you start from CLI, and then it's harder to do. And I agree with you with the lower level, and that maybe also to answer Alex, is that, okay, there are things that we know from the config of the service. There are things that we know from the network, right? I mentioned example with ISIS. Well, your service model will not configure ISIS. The IGP is there by default, right? So as a consequence, you need to learn it from the network. And there are extra things that we want to have, like I mentioned, multicast, right? We might want to see if a specific service is multicast or not. And there we might need to have the operator input to construct the first graph. To construct a graph the first time we got a new service type. That make sense?
Yeah, I mean, the whole concept of, let's say we have two different levels, right? So it seems like, just let's take I mean, ultimately, I think there will be multiple levels, right? But just the fact in the most simple case, we have two levels, let's say the service level and then the per device level configuration. Forget about the CLI stuff, agreed, makes it more difficult. So device config is also Yang, but purely, the abstraction models by which I can say, oh, okay, here I'm looking now at the device level configuration, but attached to each, I don't know, level or something else in the Yang device level configuration are pointers pointing back to the services that are requiring this. So that I'm basically this attribution.
This is what we've got in slide 7, right? Where we just say we've got the top of the assurance graph is the service ID that comes from the orchestrator, and this is the top of this tree comes from the service, and this is the link that you need.
Right. So, oh, okay. Right. So, I mean, this was very fast, and I think
slide 7. This is this one. Yeah, the tunnel service instance there. It comes from the orchestrator, and this is something you configure, like an L2 VPN, L3 VPN with an ID, with a customer, with a tenant, whatever. And then for that specific instance, you've got the entire tree there.
So you would say that one of the overheads might be, if I want to be able on a router to kind of see the service dependencies, then the router ultimately would capture the whole tree, even if he isn't doing anything.
I didn't mention that. I mentioned distributed. The router would know about part of the sub-services, the device health, the interface health, telemetry health, whatever, but not the entire tree. However, because it's Yang, you could just have a leaf ref, right? And okay. So let's take it offline, I guess. So Laurent, this is what you want, right?
Right. So you have, and all of these are existing Yang structural elements, or does any of this requires, you know, structural enhancements to Yang?
No. Yang.
Thank you.
Thanks, Benoit. Thanks, people, for the nice interactions. So I think we can keep having, again, interaction with this document. I know it's also progressed more in Ops AWG. But I think there are, again, links to the activity on IBM in the research group. And as Benoit mentioned in his last slides, he expects further reviews and feedback on the completeness of the concept that he's considering. And I think any review and feedback are always valuable. So I would like to maintain this link active to the extent possible, and we see how it goes for the next steps. Thanks, Benoit. So next in the agenda will be a very quick updates. I apologize to everyone for the exploded agenda. We have planned maybe too much stuff. We're already much over time. We will try to go very quick on the last technical presentation and give save a few minutes to give some research group updates to the people that can still be connected at this time. So the next presentation will be on the update on intent-based networking concept and definition draft. Let me grab the slides. This should be very quick, hopefully. I will present as a co-author the quick updates. So this draft is this is a version 1 of draft IETF NMRG IBN concept and definitions. Very recent history. So this document was adopted as research group document in December last year. We made some changes in version 01. Essentially a complete editorial review of the document. We have also revised and aligned definitions for intent throughout the document. This is based essentially on interaction on the mailing list and with the draft on intent classification, which triggered let us know about some inconsistency in the definition. So this was a good catch. We have also reworked and improved refined text for the section 5 on principles. Some of the principles were also a bit slightly reworked. We swapped section 6 and section 7. So now the new section 6 is functionality and section 7 is life cycle. This allows us to explain a bit before going into the details of the diagram, a bit more in a higher level, the main functionality and the composition of the intent life cycle from a textual point of view, description point of view, and then we have in new section 7 the life cycle diagram and some quick explanation of the diagram. In this life cycle section, initially we had two kind of competing diagrams. So we decided to keep one that was comprehensive enough to cope for the different elements of the life cycle we thought were essential for the draft. We still have to consolidate a bit further and still improve a bit on the description of this life cycle, but now it's a bit more clear also for the external readers about this single life cycle diagram. And I think one of the major updates we made in version 01 was to add a complete new section on security considerations. Before that, we knew we wanted to address security consideration, even if it's a kind of conceptual document. But since IBM is not a completely new topic, but it addresses a new approach to how we do network management, we felt necessary to think in broad terms how the security consideration should be approached for IBM. So I invite you to have a look clearly in this new section and give us some feedback. So this is for highlighting the main updates from version 0, which was adopted to version 1. I'm not going into the details of the document structure, the details of everything, because we don't have time first, and also because all this was the status we had in the meeting in Singapore and in December. This has not changed. It's mainly some re-architecturing and improvement of the text. For the next steps, we are working on the version 0.2, which should be available anytime soon. We will continue to improve the, I would say, the text of the draft. We still have a few principles that we wanted to add. They were in the kind of to-do list, so we will provide inputs for that. We will also work since the concept and definition draft, slightly improve also the section on acronyms, terms, and definitions to have proper entries into this section of the document with respect to the concepts and definitions defined throughout the text. As I said, consolidation of the life cycle diagram. We will also collect any feedback on if this is complete and good enough to proceed. And we have some pending comments and reviews that we received some months ago and more recently that we need to integrate in the different sections of the document. So this is pretty straightforward in terms of evolution, knowing that this document we believe is pretty stable. It's not finished, but we don't expect to have major re-architecting of the structure of the document. So according to the research group milestones, there is a target to send this document, the corresponding documents, not necessarily only this one, to IRSG review by November 2020. So this is still in our plan, but it will depend how we move on with the next version and the comments we may receive for that. But in our perspective, as a group of co-authors, we think it's becoming more and more stable, and it would be nice to reach these targets by the end of the year. That's it for the quick update on this document. Any comments? If not, okay, thanks. So we are now going to continue with the chair slides and conclude this meeting with some updates on the research group. So to browse quickly, Jérôme, also don't hesitate to add things on my flow. General information, we had our new charter approved end of March, so this is still quite recent. So congratulations and thanks to everyone that participated in providing inputs, comments, and support for the revised charter, the inputs in terms of technical content, review, etc., and also to our IETF chair for bringing this forward. We initiated that a long time ago, but I think it was really useful for bringing a very nice research agenda for this long-lasting research group. And now we have a long list of very interesting and ambitious items to investigate. I just copy-paste a quick snapshot of the milestones you can find on the data tracker. It's not usual for a research group to have milestones, but we believe that some of our work items deserve it, and it will help us also to try to put energy and a bit of pace in our research there, because I think the industry is expecting also some answers, and work could move towards also IETF and other groups. We have also initiated a few months ago the GitHub organization for NMRG, so you can find the links here. We invite you to join as contributors, and we will planning to host repositories for, of course, research group documents, but we can also offer repositories for individual documents if you want to host it there. Also for the code, we have a few implementation on IBM proof of concepts that we are going to port there. And also we are looking forward, we are looking in how we can use also GitHub maybe as a rendering engine for kind of website version of the different resources hosted by NMRG, so that this is a bit more easier access than the data tracker for people that are a bit less connected to the IETF processes. Jerome, maybe you can take the floor for this one.
Yeah, sure. So here is an update of the activities regarding artificial intelligence that we started in the group. So I think the first and the major thing is this research challenges document. So this is something we talk a bit, and in particular in Singapore, where we wanted to have a document in order to actually have detailed description of the different challenges of artificial intelligence applied to network management use case. I'm not sure we have time to go through the document itself, Laurent, or maybe I should just summarize like that. What do you think? We still have a bit of time. Okay, so maybe, yeah, if you can open it.
I will display quickly the document. I think we should try also to be concise, not
yes,
to
yes.
everyone.
Okay, so just okay, so now we have the document, so that will appear. But the idea is that because I know that we know that a lot of people were willing to contribute, we are submitting and so on, but we need also a bit to have some structure to have the document written. So we started to write a draft starting from a table of content that we presented in a previous virtual meeting. So the idea is this document. Of course, the core part of the document will be challenges related to AI network management. We have identified some of them during some side meetings in previous IETF, also during some virtual meetings. So here in the basically in the if you go a bit below, Laurent, you have the talk and the table of content that is okay, a bit expanded. So there are two main sections, so challenges as well, and the goals of AI in network management as well. There are the two main sections that we would like to work at this time. And of course, maybe on the section on research challenges, for each section we provide some kind of guidelines or question to answer to help people to know what type of contents we are expecting here. Yeah, as Laurent highlighted here for challenges. And so for the different challenge we have identified, but of course you can add some challenges that you have in mind. You should try to write the text in a way that you answer the different questions. And of course, you should identify yourself an interested contributor to this document. Here is a draft example I wrote on lightweight AI for network management. Of course, because you have different sections, so and also it needs to be documented with reference and so on to have already something quite concrete. And of course, then here you have item 2, 3, 4, and 5 that are other challenges we have in mind based on the discussion we had in previous meetings. So basically, if people are willing to contribute to this document, of course, we'll share again on the mailing list. Please clearly have a look on this table, look at the challenge you're interested into participating, identify yourself as a contributor here in the document, in the beginning of the document and the table, and also propose some content. So here you have detailed instructions at the beginning of the document. So you will have some kind of clear instruction. To be honest, we have a use case section in the document, but we do not request at that time content for this section because we know from previous experience that if you go directly into use case, it will be completely, let's say, separate use cases without really some kind of how to say some kind of commonalities between use cases. So here's the goal, really to more look into the challenges. Of course, in the goals section, you can provide also some kind of overview of use case, but not detailed use case at that time. It will come later in order to have a more synthetic view on the challenges. It's really our on purpose that we did that. And so yeah, that's basically the current document version. And if you go back to the slide, Laurent, please. So
see the slide?
No, but I think it may be some kind of delay. But so then it's just on the other part of the slide. Yes, so here you have just a summary of the process, as I said before. If you're willing to contribute, just identify yourself in the document. Also give feedback if you disagree with what you propose in terms of table of contents. Of course, it's not fixed structure; it may evolve. I think one good one discussion we have also usually is what is a publication target for such a document. After some discussion, we should say that it should appear kind of as a draft in the group in order to have some rapid visibility. But at the same point, it's more kind of a white paper, so it should be yes, published as white paper or journal or magazine, but it will be long-term goals. But as many people say that it's interesting to participate to such an initiative, but we will need visibility. It will be good to have this document, yes, as a draft as well. So here's a proposition. Regarding, yes, the type of way to collaborate, we'll start with Google Docs. It's just to facilitate the starting of the collaboration. It does not mean that we will continue with Google Docs. For example, if we want to use the GitHub that Laurent mentioned previously, yes, we will probably use it, but to be as most possible as open at the beginning, we will start with Google Docs, but it's not does not mean that it should be the final version, final type of tools that we will use. So here we are really willing for contributors and feedback on the process, on the document content that we would like to have. So if you have any feedback, just tell us now or in mailing list, because I know we have a bit short of time now. Maybe I'll just present the first slide, and then you can, if somebody has a question, can just raise the hand. Regarding AI, we have in mind also to organize more regular, let's say, series of talk regarding this topic, in order to have more technical talk, as it was suggested to us as well. So this is really something which is in the preliminary step. It should not be actually, we do not especially see that as only NMRG activities, but we would like to have something more global with other groups and communities at a different at a different place. But in order to have some kind of recurrent, like every month or every 2 months, to have this kind of a series. But it's very preliminary, as I said. We have also in mind this AI challenges that technical challenges or competition. So here we just mentioned two existing ones, not an NMRG specific. So one is proposed by ITU, and noting that registration is open. So if you want to participate to the challenge as a participant, you can follow this link. Also one which is proposed not only by, but partially by the Polytechnic University of Catalonia, about graph neural network. So it was supposed to be open soon, but yeah, with the situation, it's not clear when it will be open, and I don't think we have we don't have Albert here. Regarding NMRG, as far as I know, unfortunately all the projects are a bit stopped now, but of course it's still open. If NMRG would like to propose a technical challenges, participant of NMRG, so it's still open. But as far as I know, there is no project that is continuing for this last item. So here is a summary of the slide. So if you have any comment, question, do not hesitate.
I suggest we move on.
Yeah, sure.
Next is more a status on the intent-based networking work plan of your research group. So as you can see, this is the table of milestones we have corresponding to what we have in the charter. I tried to map everything in terms of work items with respect to basic milestones when they are adopted and go to the RSG review. The dates and a bit the status, and just wanted to highlight, okay, it's in red, but it's not critical. Okay, we are not a working group. There is no PGPP release or whatever. It's just to highlight a bit of a critical situation in terms of where we stand with respect to our initial goals. For these three items, the other ones are a bit more on track. So just focusing on the first one, the first work item we had was document the problem statement, design goals and challenges for intent-based networking. We initially had these three first work items together as a batch. We wanted to reach research group adoption by the end of last year. Unfortunately, we have no corresponding documents currently for this specific work item. The initial goal was to describe the problem and solution space, identify the limits of current technologies and methods, and derive the associated research challenges. So it doesn't need to be a very long document, but at least I believe, Jerome and we believe that this is of utmost importance that this work happens in the research group because it helps us to define clearly what we are trying to solve. Okay, we are already engaged into other documents, but I think these aspects of the problem statement goals are important. I see Alex in the queue, but let me just finish with the slide and I take your comment. As possible next steps, this is just open proposal. We may refine them, of course, to come up quickly with a new document to address specifically this point, or to move parts or all this work item to existing documents, for instance, the draft IBN concept and definition, or we can at least, in the last resort, drop this work item, which I don't encourage us to do, and we prefer to find alternatives. Alex, you wanted to comment on this?
Yes, yeah, I was just wondering, so basically, so you say, I'm wondering basically, is there somebody working on this right now? Or is it just that there's really no document and basically we're waiting for someone to create a new one?
There is no I would say individual documents that have been proposed towards the NMRG. I mean, personally, as an individual, I'm working on that for Nokia. So we have a draft, not a draft, but a draft document. It's not yet ready to be shared. So if we could contribute that to NMRG, but we have to find the right window to do that. And yes, it will be nice from a research group perspective to have something coming in as new documents or based on something else, but this will be appreciated.
Okay.
And
thanks.
we can collaborate. I mean, it's not necessarily needs to be a one person or one organization document. Of course, this is completely collaborative by default.
Sure, yeah, I think if there's a need, and I think there's a lot of people who are very motivated to work on stuff here, we should take it up. So I hadn't really been aware, so thanks for pointing this out.
Yeah, okay. So it's something we can share also on the mailing list or point to point with the people that are interested. At least raise the call for contributions to the mailing list and see if we have a group of persons interested to quickly move forward with this one. I don't believe it's so complex or difficult. It's just that we have this in our work item and a bit milestones. So if we can achieve that, it will be better to be consistent with what we have defined in the charter.
Okay, thanks.
Okay, the second one is still in the work plan for intent-based networking, but it's addressing a different part, which I think is the most important one we should work on in the research group. So this is about so-called architecture. So the goal was to determine the elementary functional blocks of an IBM system, their interactions, input and outputs, and propose different techniques applicable for the different functions. We are planning to have something as an early research group adoption for July this year. Currently, we had previously some individual documents that were addressing this architecture discussion that are expired now. There have been a few meetings where we have had technical proposal towards this architecture discussion, but currently we don't have active documents and new proposal for that. So I believe it's a very central piece of the IBM work plan to be able to come with this common architectural framework, especially in continuation with what we have currently with the intent classification and concept and definition. Possible next steps, again, to come quickly with new documents or reactivate expired documents to really respin this activity. And I think really not, I think beyond the restarting of this activity, we should really increase considerably the level of activity in the research group on this item, because this is a big piece of work. We don't go into formal specification, but at least this reference model will be very useful in order to help different pieces of the solutions to come together. We have seen that, for instance, Benoit with his work in ops. There are other works also in ops that are of interest. In Anima, there have been also some calls in the past. I think there are many groups and expectations, and if we can contribute with something that helps to reach this common architecture view, it will be very helpful. The next one, okay, sorry. Okay. Next one is item 5. This one is more on so-called use cases or validation scenarios. It's a bit the same situation. We wanted to go towards having some preliminary results and documents end of last year. This was okay. We had this, but we don't have the corresponding documents. We had some proof of concept demonstration in October last year. But it's important from a validation point of view. And so potential next steps to come again with documents like use case documents, experimental or implementation description that could show how concrete application of our idea and concepts in real settings. Also improve the links with implementation and proof of concept. This is the item 6 in the work plan. So as I say, we have some proof of concept demos and tools that are being developed, but we need to have the corresponding description of those experiments to be able to progress on our work plan. And again, the level of activity in that space should also increase. Luis, you had comments? I don't know if it's on this one or the previous one.
This one, Logan. Yeah, my comment is that I wonder if the transport intent that I presented could be considered as a use case for this. I think that from my point of view, yes. I would like to know what is your perspective. Could you hear me?
Yeah, sorry, Luis. I say it was a bit difficult for me to hear you. Can you repeat the last sentence, please?
Yeah, sure. So I was basically considering that probably that the transport slicing could be a use case for this. So I would like just to know your opinion on that.
Yeah, this is a very good point, because when I was reviewing a bit the content for this meeting, I thought that the work that you are proposing with the transport slice intent and also the thing you proposed before that are actually could be really related to that. We can have a use case around transport slice or a kind of using network provider plus vertical interactions for instantiation. This could be a way to see a kind of experiments or use case with concrete boundaries to that. And I know also that you're also on this number 5, also working on corresponding, test beds and proof of concept. So I believe if you have willingness to contribute, this could be a good starting point, yes.
For sure, and also if we could link with the IETF activity in the peace working group, I think that we could have a very nice story on this. So okay, thank you.
Yeah, okay, we can interact further to see a bit the positioning of your draft in NMRG. Yeah, thanks you. And next, okay, let me go back to this. So finally, for last update on the intent-based networking work plan, we also had in mind we have this hackathon project. We wanted to contribute with a bit more practical aspect of IBN. What we are going to do is to consult with the different involved teams that we managed to contact, that we know have plans in that space, interact with them to define a proper scope and objectives of what we would like to achieve with such a kind of hackathon project. And for an overall planning when we think we can be ready with respect to the objective and align with the research group milestone. We initially had in mind to target participation in the next IETF meeting in July in Madrid. There are still some uncertainty from the meeting point of view, if it will be in person and what will be the ability of people to travel or to participate on site or remotely. So this is very open and uncertain. So we have to reassess the practicality of targeting something concrete for July. It doesn't mean that we will not work, but we have to understand if it will be a bit more different teams, different settings. We have to see what will make most sense. And also for the future, maybe more at the end of the year. So we will communicate towards the research group with a bit this framework that we would like to pursue, so that everyone can be aware and can express interest and willingness to contribute. And of course, if you have any willingness to support and help us in this, we are really welcoming and brains. Last point in the technical update for the research group, we have a third research activity, which is more towards the self-driving, self-management frameworks. So our idea, so this is just to host a forum of discussion to see a bit what's going on and how it can influence further developments of internet management and operations. What we observed a bit was that we could organize a kind of dedicated session based on what we have seen recently, inputs coming from different groups, especially the Ops area working group, where we have seen this ECA framework for self-management, or work from automating service and network management framework, service assurance for IBM architecture that was presented at this meeting by Benoit. So there are already in Ops several works that are touching architecture, closed automation, policy-based management, automation. So all of correlated items that are being progressed by different organizations, different groups of persons. In ANIMA working group, there are also this reference model and ACP that are finally will be able to move forward. So this can be also a way to reconnect with some architectural work that was pursued in ANIMA. There may be also other working groups. This is not exhaustive. There have been also more recently some publication of specification architectures in other SDOs, such as HCZSM or ENI. We can also invite them to participate, and of course try to see also from other, we'll say, research or even less researchy academic and industry initiative on network management architecture. So try to bring together these different initiatives and proposal and see commonalities, trends that are emerging and make people discuss together. We could have this for the next IETF 108, maybe the one after, if it's more relevant in terms of organization, dedicated virtual meetings. We are really open to the best option, and we are welcoming your opinions on that. Okay, so I'm just continuing because we're already quite over time. Finally, just a very quick view on the future meetings. So next week, we should have had a in-person interim meeting in Budapest for the IEEE NOMS conference, but the NOMS conference will be fully virtual this year. So we decided to cancel the special session on NMRG, because the idea was more to meet people and gather with the different communities. But NOMS is maintained. It will be a virtual conference, so you can still register and attend this very good program that will be next week. All the keynotes, all the technical speeches. We had also planned a special session, a dedicated meeting with the IPOP conference in Tokyo, but again, this conference has been moved to September this year. So we currently have to cancel our plan for that, and September was not a good slot to have NMRG participation due to absence of the chairs. So we decided to cancel our participation for the moment. We may investigate for participating maybe next year again. We have a meeting in July in Madrid, which is currently maintained, even if there are plans to consider face-to-face or virtual meetings. But we have there, if we make some targets in terms of hackathon and several research group milestones. So this will be an important time of the year for us. The main message for the future meetings here is that we want to say, until further notice, the default mode of operation will increasingly rely on 3 virtual meetings. We have already done that for a few times now, so it's we are quite used to it. We want to use more the mailing list to host our technical discussion, and also rely also on collaborative platforms, as you have seen, for instance, with the document that Jerome highlighted with Google Docs, if it's accessible for people, or for different drafts and activities. And of course, do not hesitate to share your questions, ideas, or needs with the entire group or the chairs. We know that it may be difficult for some of us to reorganize since we are not meeting face-to-face for. Alex, you wanted to raise something before? I saw you've withdrawn, but maybe you still want to share.
Oh no, so I just wanted to mention that this is a misleading, right? NOMS has been cancelled. It's the meeting that has been cancelled. So NOMS is virtual.
Exactly, yes. Yeah. The IEEE NOMS conference will not be an in-person conference. It will be mentioned virtually. It's next week. A lot of talks that are scheduled, but the NMRG participation to NOMS is cancelled. That's it for research group updates. Jerome, I don't know if you want to add something.
Oh, no, nothing else, Laura. I think you said everything regarding the updates. Oh.
Okay. So on my side, I would like to thank a lot all the participants. It was challenging to have this very long meeting, especially because we are covering a very diverse time zones. So thank you for all the ones that had to stay up very late or wake up very early. It's always a challenge from our perspective to find the right slot, but thank you for your very good technical presentation, very good interactions also through the chat. I hope we will get very good minutes and able to continue. I've seen a lot of new inputs, very good technical discussion that are a lot of potential. So I'll things to progress. And again, it's contribution driven, as we say. So please continue working like this. Thank you very much. Have a nice whatever part of the day you have left.
Thank you very much. No. Thank you. Bye-bye.
Bye, thanks.